Hello, hello, good evening, everybody. We are live once again. I hope you can hear me well. Let me check. Work. Hello, yes, I can hear myself. I still need to learn how to do that, how to, manage my streams well, so I don't have to do that every time. I know it could be annoying for people, but today we are going to learn about arrays and slices in Go. And yeah, we're going to explore it um, and see how far we can go. My intention is to just only go arrays and slices and stop there. And I aim to stream for 2 hours, not keeping it too long, and give my mind some processing time as well. In the last stream, we learned a lot about extracts. We learned about pointers, which were kind of a scary topic for me, but I got I think I understand the concepts of pointers quite well now. I'm not sure if I can call it quite well, but I understand what they teach us in the documentation in the tour of Go. So hopefully that's gonna be helpful. The real learning is gonna come when we are gonna be building real application. Then we're gonna see a lot of good use cases for it, and especially when it comes to game development, which I intend to do as well in the future, browser-based gamings, because I firmly believe that building games is gonna give you a lot of insights into internals of how actually things work, from APIs to WebSockets. So these multiplayer games, I think they can teach you a lot. That will be my goal in the future. But before doing all of that, we need to obviously uh, we need to learn the basics. We need to learn the fundamentals, make sure we got the fundamentals right, and we are just gonna be moving. Um, I believe nobody's gonna be watching this at this point, and if you are, that's good. But I'm gonna put a message here. No, I think it's okay. We usually don't do that. We usually do that, but today we are not gonna do that. That's fine. And what I will do is I will just go here, a tour of Go. We came here from the documentation. We started a tour of Go, and I think we're gonna continue now with the tour of Go. But we also have ChatGPT opened here as a helper for us to navigate through our challenges, things that we don't understand, things that needs to be explained a lot simpler. And as I mentioned in the previous streams, Go documentation is not quite beginner friendly, so I think I will definitely need that. The concept of slices was also introduced when we did one tutorial. I don't remember exactly when, but we were actually learning already about slices. I think it was when we were doing the tutorial, the beginner tutorial in the documentation. Yeah, I'm already familiar with the concept of arrays. The data structure is quite similar to a lot of other programming language, but slices are something interesting here. And yeah, the fact that they call it slices, yeah. But we went through that as well, but we're gonna pretend that we don't know anything about them and learning everything from scratch. As usual, there's no coffee this time because yeah, it disturbs my sleep. I think yeah, I was quite wrong about it not impacting my sleep, but it could be also something else. I don't know, but coffee is not doing good to me recently. And I always forget to create another stream for Twitch. I don't know how to do that yet. I need to figure it out. But here we go. We are back in a tour of Go, and we are learning arrays. Amazing and exciting stuff. Let me make sure my phone is also silent so there are no notifications. And we are in the focus mode. All right, arrays, the type in T is an array of n values of T. The expression var a10 int declares a variable. This expression declares a variable a, an array of 10 integers. This is the size or the length of the array. This is the type, so the data type. In this case, it's going to be an array of integers, and we're going to store that in a variable called a. An array's length is part of its type, so arrays cannot be resized. This seems limiting, but don't worry. Go provides a convenient way of working with arrays. I think what they mean is slices, right? That what they mean is slices, but I'm not gonna. Let's pretend that we don't know about it. So yeah, here they provide an example. Let's first understand it, then we are gonna implement it. So a string of 2, an array called a with a length of 2 of type string. We can assign the first index to hello and the second index to world, and we're gonna just print the first, print the second, and we're gonna print the whole array basically. We're gonna see how that's gonna give us. And this is an array of prime numbers, the prime numbers of length 6. So we have 2, 3, 5, 7, 11, 13. And a prime number. I hope you you know what they are, because I'm quite bad at math, but I know what prime numbers are. They are the ones who can either be divided by themselves or 1. Am I correct on that? So it cannot be any other. Yeah. Anyways, that's besides the point. Let's see how we can do it. I'm gonna come back here. So all the arrays or all the variables start with a keyword var, and let's say we have 2, size of 2, right? And then the type is a string. So this is gonna be an array of strings size 2, and we can say a0, the first index of the array, is gonna be hello, because its type is string, right? And the second, the second index is gonna be world. And easy peasy, we're gonna fmt dot print print line. Should it print line or print? It doesn't matter. I would say A0, right? And A1. And we're gonna also, what we're gonna do is, we're gonna print the whole array as well to see how does it look like. All right, it doesn't seems to be any error. So we got hello world, and you can see on the second line we got the whole array. Here is the array, but it's interesting that it doesn't provide a comma here, which I was expecting, because it's separated by a space. A delimiter space is not as common, especially working with arrays and stuff. But okay, we got that. And then let's see if we can get the primes right. So we have a primes. This time we're gonna declare and initialize it in the same line. This is gonna be, let's say, of a 6 as said in the documentation, and it's gonna be type of integers, right? And we gonna, is it curly brackets? Yes, I'm right. It's curly brackets. Now I'm gonna be 2, 3, 5. No, I'm not gonna be. The array is gonna be 7 and 9. Is not 9? Is not 11 and 13. Okay. What happens if I do one more? Let's say 17. I think we're gonna get an error saying that index 6 is out of bound as expected. So let's remove this again. And yeah, we can fmt dot print line. We can say primes. Let's print it first. index, which is going to give us 3. Okay, whatever that was. Okay, we have 3 there. We have 3. All right. How can I print the length, for example? Can I print length of primes? For example, primes, if I type primes, it's gonna give me the whole thing separated by comma. Ooh, what is that? Length of primes. Yeah, that's how you do it. Similar to Python, you can do that as well. It's gonna give me 6. Okay, that's good. We learned about arrays. I already knew about it, but a collection of similar items, a collection of similar types. Similar type or same type? Same type is a good choice of word. Same type. So it could be either integer or a string. As you can see here, we have an integer on line 9, and on line 16 we have an array of integers. On line 7 we have an array of strings. That was not hard. And let's move on to slices, which is flexible arrays. That's what we understood so far. An array has a fixed size. A slice, on the other hand, is a dynamically sized flexible view into elements of an array. In practice, slices are much more common than arrays. That's for sure, because who wants to define the length of the array? There are times that you don't know this. I'm sure you're not much flexible with this, but I could imagine maybe the fact that there's we have this option, maybe it's gonna make the program more efficient. You know, like maybe in terms of memory allocation and all that, the program is gonna be, you know, like expecting an array of 6, and the placement of it in memory could be more efficient. I don't know about that. That's just I'm wondering. And this time I'm not going to ask ChatGPT or Google it, because yeah, we could easily get sidetracked. But it's always a question of why is always important. So you should always be asking questions. Why? Why do we need to even specify the actually, you know what? I'm gonna ask ChatGPT. I'm getting more curious now. So what is the benefit of specifying array size in GoLang? Size does matter here, does it? What is the benefit of specifying array size in GoLang? For example, the following. Does that make my program more efficient as compared to using slices? Because again, we have the option to use slices. I wonder why we can do this. What is the point of it, basically? Why we have the option there? Okay, ChatGPT, let's say in Go, specifying the array size is like the example, blah, 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 does not necessarily make your program more efficient in terms of performance compared to using slices. However, there are some subtle differences between arrays and slices that may impact performance or memory behavior in specific scenarios. Memory allocation. Array is a fixed data structure. When you declare an array with a specific size, Go will allocate the exact amount of memory for it. In that case, it allocates enough for the 6 integer elements. This is something that I predicted. This is something that I assumed beforehand. It makes sense to me. Slices are more flexible. They are a view or a reference to an underlying array, and they can dynamically grow and shrink. When you declare a slice, Go does not immediately allocate memory for the slice elements unless you initialize it with values. A slice typically has a reference to an array with a length and capacity. In terms of performance, accessing elements in both arrays and slices slices is equally fast as both are backed by continuous block of memory. If you know that the size of your collection will not change and you don't need dynamic resizing, using an array may save some overhead. However, this is more relevant to memory usage and less about raw performance. Yeah, maybe I mislabel it as performance. It's yeah. At the end of the day, you know, coming from a systems background, if you manage memory more efficient, good for you, because the server is gonna be much happier with that, and a systems guy is gonna be much happier with that. Um, but yeah, with slices, with a slice, even if it starts with a small initial capacity, it may grow dynamically as more elements are added, which can cause allocations and potential reallocations, impacting performance under certain conditions. Example, frequent resizing. Okay. Pointer semantics, array in Go are value types, meaning they are copied when passed around. Slices, on the other hand, are reference type, meaning they share the underlying array and passing a slice does not copy its data. Beautiful. We already know about pointers now, so I'm not going to explain this. If you haven't watched it, go watch my previous live stream about pointers. It's a very interesting topic, and it was something that I was a little bit intimidated by it my whole career, including when I was studying it during university. But now, at least so far, I think it's less scary to me. Hopefully, I will be able to use it. But as we know, Go is much more flexible. It's more like things are happening behind the scene without you actually doing the hard work in many cases. But you also have the option to extend it and to play around with it. You have more control over it. So that's really beautiful. This can have performance implications if you're frequently passing large arrays around. Okay, I'm not gonna continue end to end, but in conclusion, specifying the array size in Go does not inherently make your program more efficient compared to using slices. In most cases, slices offer more flexibility and are used more frequently in Go. Arrays may have a slight edge in terms of memory overhead, but this difference is usually negligible, okay? Unless you're working in performance critical applications, which again, I think gaming and stuff, probably. I think gaming is a good example of this. Low-level systems or embedded programming where fixed size data structure could be more predictable. Okay, we already know the question of why. That's nice. And now we can go to slices. An array has a fixed size. A slice, on the other hand, is a dynamically sized, flexible view into the element of an array. In practice, slices are much more common than arrays. Honestly speaking, coming from a Python background, you know, where everything is actually interfaced, everything is, a lot of things are happening behind the scene or under the hood. You don't see a lot of things. It's much more high level. Yes. So I think practically you probably don't need to use a lot of arrays in your life. I think slices are much more flexible. I don't know if you're again if your application is super sensitive in terms of memory allocation, then yeah, arrays. But as a programmer, that would probably make your life a lot more difficult. But yeah, the type empty square brackets. Is it square brackets? Yes. Is a slice with element of type T. Okay. A slice is formed by specifying two indices, a low and a high bound, separated by a colon. Also, we have a capacity. We know about capacity in slices. This selects a half-open range, which includes the first element, but excludes the last one. The following expression creates a slice, which includes elements 1 through 3 and of A. Okay, let's see the example, actually. So we have a prime, number of prime. This is how we did it just previously. We could also do something like this. Variable S. Variable S is a type of a slice of an integer. Did I say that correctly? Is a Slice is an slices of integers. Yeah, I think so. It's like an array of integers, slices of integers, prime, and then it's gonna be primes. It's gonna be 1 and to 4, and let's see what we're gonna get. So this is low, this is high. This is gonna probably give me 1, 2, 3, 4, right? Or at up to 3. I don't know. Let's see. So what I will do is I will come here, and maybe I'm gonna keep the primes, for example. All right. Now we're gonna say, and we're gonna say var is. I'm gonna leave it empty of type int. Is it empty? Okay. Then yeah, and then we're gonna primes. Oh, look at that! It already pre-filled that for me. So 1 to 4. Let's put it that way. And oh, I misunderstood it, guys. I misunderstood it. So here we are saying from index 1, from index 1 to index 4. So it's gonna be 3, 3, 5, 7, 11. All right. So if we print is, if empty dot print line is, that's what's gonna happen, I think. 3, 5, 7, not including 11. Yeah, 3, 5, 7, because up to 4 not equal to 4. So yeah, something like that. It's weird kind of that they gave this example, because okay, I know that this is sort of specifying the range of the primes, but we are talking about slices. So I don't know. Maybe they could give a better example. I would assume. All right. So in short, slices are arrays which are which are flexible. Unlike array, which is a fixed size, this one is dynamically allocated. Slices are like references to arrays. A slice does not store any data, it just describes a section of an underlying array. Okay, that makes a lot more sense now. Sometimes for learning stuff, I think if you learn something once, it's probably not enough. You need to repeat that. You need to learn it again, because I remember we read about this in a live stream. We know about slices; they are flexible arrays, but the fact that slices are actually not themselves, they don't occupy physical memory, right? Instead, they are a reference, similar to pointers to. They are probably exactly pointers to arrays. So in other way, we have arrays, and then they have tried to build something on top of it. That gives you much more flexibility. That's why I think this example here. That's why they give that example. So, but you can also specify slices right away without having an array beforehand. Obviously, otherwise, what would be the point of slices, right? So that's why I think this example is probably not a good one in a way, practically speaking. But maybe I'm wrong. Changing the elements of a slice modifies the corresponding element of its underlying array. Other slices that share the same underlying array will see these changes. Can we go and draw something here? So we have an array. All right. Oh my God, what was that? We have an array. Let's say it's of integers 1, 2, 3, 4. This is our array. And slices are built on top of the arrays. So here is our slice, right? It's I will just leave them empty, and yeah, maybe this is open. I don't know how do I yeah, this open means they are dynamically allocated, and they are basically a reference to an underlying array. So if you change a slice, let's say through a slice you change something in the array, if there is another sort of slice, right? Another slice will see the change. For example, if you pick this index, which is index 1, right? So this is 0, 1, 2, 3, and then you make some modifications to it, and then you have two slices that are actually, let's say we have two slices. Slice 1 is going to be, slice 1 is going to be 1 and 2, right? So it's going to be 1 and 2, and slice 2 is going to be 2 and 3, right? Or 2 and 3 and 4, it's fine, 2 and 3. And obviously, if you make a modification to this value through any means, because slices are simply interfaces to arrays, if you make any modifications to one slice, let's say here, I will just say slice 1, slice 1, and then I'm gonna put the, give it like an index. This is, in this case, this is gonna be index 1, right? So I will say 1 is equals to 3. In that case, what it means? It means we modified the underlying array. So we modified here. This is going to be 3. Therefore, whenever you print this one again, for example, this value is going to be 3. You know, let's make another color. This is going to be 3 because we changed. I just wanted to make sure that's clear for myself. But okay. Changing the elements of slice modifies the element. Okay, that's what. Other slices that share the same underlying array will see those changes. I think that's what we exactly discussed here. Cool. I like slices. The only thing that I found a little bit that I forgot about is that yes, that's what, and that's exactly why I draw. So hopefully next time I don't forget it, that array slices are sort of abstracts of arrays. Like it gives you more flexibility on top of an array. That's something we didn't. Did we read something about it like that? It's asked. Doesn't a slice, or isn't a slice an abstract or interface, how to put it, of an array? Yes, you can think of a slice in Go as an abstraction or interface over an array, but it's more accurate to describe it as a view or wrapper. Yeah, that's the word that I was looking for, probably. A view or wrapper around the array rather than an interface. Let me clarify the relationship between the array. Okay, thank you. I think we understand it. But let's see this example. So I think probably here we're gonna do something similar to this and see it in action. Let's see. We have names. We have an array of names. How do we know it's an array? Because it has a fixed length of 4 and is of type string. We have John, Paul, George, Ringo. And if we print names, obviously it's going to print the whole array separated by spaces, because that seems to be the default delimiter here. But if we say A, now we are going to change, right? We're going to change A. We are defining a variable A, and this is a slice. And then we have B, which is going to be from, this is going to be from 0 to 2, which means it's going to be 1, 2, this 2, 0, 0, 1, and then from 1 to 3. So, and also that means from 1 to 3. So it means not including 1. So it's going to be only George, I think. Is it? If we print A and B, and then we modify the B to XX, and if we print A and B and print names, I'm sure that this time it's going to be changed. Let's give it a try. So we have an array of names. How we can do that? We have var names of 4. Was it 4? I think so. Of type string, and we're gonna initialize it. We're gonna say John, Mark, Rooney, and who else? Luca. Here I think probably I need to put a comma, or it doesn't matter. Okay, whatever. And let's define a slice, and this time it's gonna be a slice of type, a slice of names, and from 1 to 3, yes, from 0 to 2, sorry, from 0 to 2, and this time it's gonna be from 1 to 3. Okay, and then if gonna print fmt, of course, dot print line. First of all, I want to print names, right? This is the original array. And next I want to print A and B. After that, we're gonna modify the one of them. We're gonna modify one of them, in this case B. We're gonna put the index of 0 to XX. But before doing that, why don't we just print this so that we know what we are getting? But there is an error here. I know why, because we don't need to use this one first of all. That's at least one, and then we need to put a colon equals. Oh, I'm doing it in the wrong side, see, this is why you need practice, right? The for didn't matter if I put it up. Let's put it for, just to be sure it works. All right, so we have John, Mark, Rooney, Luca. That's our whole array. We are printing it, and this is from 0 to 2. So we have John and Mark, right? So we have 0 through 2. So it's gonna be 0 and 1, right? It's not gonna include 2. And then we have 1 to 3. So it's gonna be Mark and Rooney. It's gonna be Rooney and Luca. It's gonna be Rooney and Luca in the second one. No, Mark and Rooney, because this is gonna be included one. So it's gonna be Mark and Rooney. And if we now change, if we change B 0, which means we are changing the first index of B. So this is B, right? So the first index of B, we're gonna change Mark to something else, right? Okay. Equals to, for example, C. C is another snooker player. And yeah, by the way, those are all snooker player names. John Higgins, Mark Selby, Rooney O'Sullivan, Ricky Bressel, if you're a snooker fan. Okay, now what's gonna happen if I fmt dot print line names? The underlying array is gonna change, right? Yes, so we have John, C, Rooney, Luca, because we modified it. Right? So we modified the second item here, the first item or the first index of this slice, and that will modify the underlying array. But again, as I mentioned, you don't need to have an array to work with slices. That's going to happen under the behind the scene. But here, obviously, just for learning purposes, this is how we are doing it, I believe. But yeah, I think we understand this. We're going to move ahead and slice literals. Do we have anyone here watching? No. It's going to be... people are going to watch it later. If you're new to my channel, hello. My name is Rashid. Welcome to my channel. I'm happy that you clicked on my video. I don't know. It means that you're probably interested in Go. And yeah, unless you randomly click around. So please subscribe to my channel, and I will be working with Go, and I will create applications with Go and do more live streams like this. So yeah, nice to meet you. And yeah, let's uh, let's see how consistent we can keep this channel and how big we can grow. To be very clear, I'm not doing it for the purpose of building followers. That could be a really nice thing, obviously, but more to share how I learn things, to you know interact with people. Hopefully, once we have the Twitch streaming set up, we're gonna do a lot more. We're gonna interact with people, get the suggestions when we build applications and so on. So it's gonna be a lot of fun. Okay, the literal, a slice literal is like an array literal without the length. Okay. I was probably using the wrong terminology then, because here a slice itself is actually, so basically what we are going to be using is a slice literal, right? Not a slice itself. This is probably what you're going to be using more often. Am I correct? So we're going to be using slice literals practically, and not slices if we really need, let's say, a flexible array. Yes, you're on the right track. In Go, slice literals are commonly used for working with flexible arrays because they provide a clean and easy way to define and initialize slices. However, understanding the distinction between slice literals and slices in the context of Go's slice type will help clarify when to use each and why slice literals are often more practical. A slice literal is a shortened way to create and initialize a slice with set of values. Slices are built on top of arrays, and a slice literal allows you to define a slice directly without needing to first define an array. That answers my question earlier, because I was like, probably this is a wrong example. That's what I said. I said this is probably a wrong example, but no, actually you cannot do any other way, because a slice needs to be, and I think now it makes a lot more sense, to be honest, because here we are slicing basically. See, we are we are taking this array and then we are dividing it into two parts, like it's a slicing. That's why. And I think slice literals are the most useful and practical way, because not every time you're going to be defining an array and then creating slices on top of it. Instead, it's going to be initializing, it's going to be declaring and initializing a slice in the same line. So the array part is going to happen under the hood, right? Okay. So three boolean, true, true, false. This is a slice. This is a this is an array literal. Okay, array literal, and this creates the same way as above, but builds a slice that references it. Okay, I think we understand this. So we have a queue. This, because this is empty, it's this size is empty. It means it's a slice literal, and it could be any size. And this time we're not gonna get any complaints from the compiler saying that, hey, you need to you're out of bound or something. We're not gonna get that. Okay. What we're gonna do here, for example, if I do queue, and this time I'm gonna keep it empty and of type integers, gonna be like 1, 2, 3, 4, 7, 78, and it doesn't matter how far I can go. That's totally fine, because this is a slice literal, which underneath it's gonna translate into an array. Again, when you declare a slice like this, it's not gonna be allocated in memory, right? Initially, until the size is known, I think, and that's how I'm thinking. But I want to ask ChatGPT about that, So the Go runtime does not allocate memory to slices unless they are used, or when does it allocate memory? Yes, you are correct. The Go runtime does not allocate memory for slices and until they are actually used. This behavior is closely tied to how slices are implemented and their underlying memory management. Let's dive deeper into when and how memory is allocated in slices. Okay. A pointer, which we already know what it is. A pointer to an underlying array, the actual data, the length, how many elements the slice currently holds, the capacity, the total number of elements the slice can hold. Okay. Before needing to allocate more memory. You can define a limit, right? That's called capacity here. You can say this helps the runtime to figure out, okay, to project how much memory is estimate, as an estimate of how much memory will likely be needed for this data structure. In this case, that's why the capacity is going to help to make sure that the Go runtime does not allocate more memory than it's needed. That's the purpose of it, I think. When does memory allocation happens for slices? When a slice is created via make. Okay, there are multiple conditions, multiple situations. If it is used, if a slice is created via make, Go allocates memory for the underlying array based on the length and optionally the capacity you specify. Example, names make int 5. I allocate memory for a slice of 5 integers with different values, and then we can print nums. The output is going to be a 0, an array of zeros, because it's already in the memory and its default value is set to 0. Why? Because we use make. Okay, if you use make, it means, hey, allocate. I think the make intentionally is called probably make. It means make a slice and put it into memory. If you don't initialize it, that's fine, but you know that the type is int. This is a size, right? This is size of slice of 5 integers. There's no capacity here, I think, but it could be like, for example, 10. It means it could go in that range. It could be between 1 to 10, right? Okay, the slice itself is a small fixed data structure that points to this newly allocated memory. Okay, let's go to the next section. When a slice is created via slice literal, like this is, we already see it, that this is not going to create anything in the memory. Memory is allocated for the slice right when the slice literal is evaluated. Go automatically allocates memory for the underlying array to hold the 5 integers. The slice nums is created with a length of 5 and a capacity of 5 because the slice literal is created with 5 elements. Yeah. So this translates into int 5 5 because we know that there are 5, and this probably like the basically taking the maximum, basically like 5, because it's already defined. So that's it. The size of it is 5. There is no flexibility around it. When you append to a slice, okay, when you append a new element to an existing slice using append function, Go may need to allocate memory if the slice capacity is reached. That's when Go decides that, hey, this needs more memory, give it, because we didn't define capacity. So the capacity is the length of the array, and then if you add another item to the array, it means Go is going to be dynamically allocating that. Hopefully we understand that correctly, because it can be sometimes that you think you understood a concept and then later on realize that you either partially understood it or you completely misunderstood it. But you have that fake confidence that you understood it. Hopefully we are not on that track. So hopefully we understand it. But yeah, interesting topic, very interesting topic. I'm not going to go into this longer. But in summary, slices don't allocate memory until they are actually created or used. Memory is allocated if a slice is created using make or appending to a slice. Then when you append to a slice, then it's going to be obviously it needs to allocate memory. The Go runtime handles memory allocation for slices automatically, making it very flexible to use. Slices grow dynamically. When appending, if a slice capacity is exceeded, Go will allocate more memory and copy the old data into the new allocation. Okay, so in short, memory is allocated only when slices are created or expanded via append and not before. This makes slices very efficient in terms of memory usage because they avoid unnecessary allocations. Let me know if you need more clarification and examples. Thank you, ChatGPT. You're such a good explainer. I know you just predict the next word, but it's helpful for me. But we're going to verify that. Again, whenever I read something from ChatGPT, I don't buy it immediately. I want to verify that. I want to see that on the documentation. But my trust has gone a little bit up, especially with things like, like basic data structures in any form, any languages. And Go is also well documented. There's a lot of community around it nowadays. So I believe ChatGPT is trained on it. I hope we are not going to see any misinformation here, but even if we see, it's okay because these are basically very fundamentals. I think we are gonna be, maybe it's not okay, honestly, maybe it's not okay, if it tells you something wrong in the beginning, I think that could sit in your mind, register in your mind, and then deregistering it and putting new information in your mind is gonna be tricky, similar to how we do it in memory, right? We register and we update. So something goes to your mind, it needs to be flexible. It needs to be a slice to be updated. So that's why misinformation here is going to be tricky if you are not careful. Okay, so let's see what slice literals are in this example. So we have the queue. We already saw that. If we print the queue, that's going to print the whole thing. And we have another slice called R, and this is going to be a type of Boolean. And we have true, false, true, 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 false, true, right? It's also dynamic. We could append it. If we print R, it's going to print all that out. And we have a extract now. We know extracts are basically types, but this time it's an extract of slices, right? It's a slice of extracts. It's a slice of extract because here the type is extract, right? And we have an I of integer and a B of Boolean. And here, which is an interesting part, we are going to define that. We have 2, which basically this is mapped to this I, right? We have 2. This could be this could be only 2 lines, or it could be this much because it's flexible. And if we print S, then it's gonna print all that. Let's give it a try. Okay, so if I fmt dot println q, that's gonna be space separated, and we have another slice called R. This time it's gonna be of type Boolean, but the size is unknown, and it's gonna be true, false, true, false, for example. And obviously if I fmt dot println R, that's gonna be similar to the other output, right? Nothing interesting here, but what we're gonna do is we're gonna see the extract, right? So we have a extract, this time is gonna be of, we have a slice, sorry, we don't have extract, we have a slice of extract, type extract, right? And okay, that's gonna be of type I, which is gonna be int, and B, which is gonna be bool, right? And expected what? Expected semicolon, found that. So if, sorry, I'm doing something wrong here. Expected nothing. What am I doing wrong? What am I doing wrong? Is it because extract I is not an expression? Okay, but wait a minute. I'm gonna define it here. So let's say, for example, we have yeah. So this is gonna be of, for example, 2 true. Yeah, now it's fine. And 3 false or whatever. Okay, so we got it. Let's keep it simple here. And fmt.println what is. Okay. So if you guys are not familiar with extracts are, which we covered in the previous live stream as well, is a type. It's like an object. It's like a class in other languages. I think you can bring multiple types into one extract, you know, like under one umbrella. It gives you that flexibility. And here we are defining 2 extracts. We are defining one slice of type extract, and that extract is going to be an integer called I and a boolean called b. And we initialize it because you see that colon and equal. It means we declare and initialize it at the same time. This is going to be like that. I think it will be helpful, I think, if this was in one line, but I know that if I move it into one line, it's going to give me an error. So let's keep it this way and run it. Yeah, so we have, there we go. There we go. We have a slice or an array of 2 sizes. We have 1 here and 1 here. And these are extracts because we defined it. These are custom types. We can safely say extracts or custom types, can we? Custom types. You define your own type. Right. All right, let's see. Let's go back. How far have we gone? Is 52 minutes, almost 1 hour. Almost 1 hour. Yeah. Because I need to know, because in my mind, I'm thinking to do this, keep it 2 hours, not keep it too long. I would say that people probably will get bored if it's too long. At least I'm boring. I'm not yet in the level of streaming where I could keep people engaged. Plus, I have 5 million subscribers only. So yeah, as you see here, 5 million. Here's ... It means it's too much that it cannot count anymore. Very, very popular person. I hope whoever is watching this, you find this helpful. My explanations are helpful to you. And I would encourage anybody who's watching this to follow along. Even if you're on a mobile device, you could probably go to go.dev/tour. Not probably, you can definitely do that. Because at the end of the day, they give you a run time here. So if I press run, yeah, you get it. So yeah, follow along. It will help you a lot. Because once, based on experience, you think you understand something until you give it a try. Then you know that you don't understand it. Or at least you don't understand it well enough. So it makes sense for you to get your hands dirty. And yeah, that's the only way to learn, in my opinion. If you don't do it, if it's just theory, if you just like, oh, I understand slice, it's just a reference to arrays or whatever. No, you didn't feel it. You didn't see it in action, even though on the screen somebody else did it for you, or in this case, the good documentation, but you need to play around with it to really understand it. And also not only about understanding, but not to forget about it, yeah? Because that's also one important part. If you don't practice it, you're gonna definitely forget about it. Okay. Right. These slice expressions are equivalents. Slice defaults. Let's I don't know why it started from here, because this is a new topic. Slice defaults. When slicing, you may omit the high or low bounds to use their default instead. Okay, yeah. The default is 0 for low bound and the length of the slides for the high bound. For example, we have a an array of, for an array like this, which is of 10 integers, the slice expressions are equivalent to, we slice it from 0 to 10. It means it's gonna be, it's gonna be the whole array, or from 0 to 10. This is also the same as this one because 0 is the default. It's also like this, it's the same, because it means minimum 0, maximum the length of the array, which is 10 already, so 0 to 10, or just leave it empty. Oops. Or leave it empty, which is even better, you know, and that means from 0 to whatever length it is. Why would you need to specify specify it like this if you can do it like this? Some people like more declarative. I think probably me also. Sometimes I like things to be more declarative, you know, like more, because then I will not get confused, especially as I'm starting out on something. I want things to be nicely in their places, and then later on as I go, I can use the shorthand versions and so on. But if you're even if you're an experienced programmer and then somebody shows you this one, you'll probably be confused. What is this? If you have done programming enough, like for example in Python we have similar concept, then you probably could guess it. But again, I would like this one much more than it's a little bit more clear. Okay, slice length and capacity. This is also something we already know from the previous live streams. But a slice has a length and a capacity. The length of a slice is another number of element it contains. The length of a slice is the number of elements it contains, which we already know. The capacity of the slice is the number of elements in the underlying array counting from the first element in the slice. Okay. The length and capacity of a slice S can be obtained using the expressions length of S or cap of S, which we already did. We did length and we didn't do cap, but I could say, we could do it as well. I mean, if I say here, fmt dot println length of S, which is gonna be 2, and this is gonna be cap of S. It's gonna be also 2, in my opinion. Let's see if I'm right or wrong. Yeah, it's gonna be 2, 2, right? Because in that case we didn't define it. That's why the length and caps is gonna be the length of the array. That's what the documentation is trying to tell you here. All right, you can extend the slice length by reslicing it, provided it has sufficient capacity. Try changing one of the slice operations in the example program to extend it beyond its capacity and see what happens. Great example. Let's do one thing. Let's first see this example. So we have a slice of called S, is of type integers, is a flexible size, obviously, and because it's called slice literals, right? Slice literals. And then we're gonna slice the slice to give it 0 length. Okay, so S equals to colon 0, and what it means is from 0 to 0. So it means it's a length of 0. If you print slices, it's gonna be length 0. It's gonna be an empty slice. It's gonna be, the length is 0, so it means it's uninitialized. Is that what it happens? An extended length. If you extend its length, drop its first 2 values. Okay. Okay. Let's do that. Again, I don't want to copy paste because I want to actually type and learn. Because if you copy paste, you're gonna assume a bunch of stuff. You're gonna jump over a bunch of stuff. You would think that you understood it, but you don't understand it. Most probably, unless you are super smart, which you maybe. Congratulations to you. But for me, I need to do it to make sure that I actually understand it properly. Um, so if you don't specify length and capacity, in this case, let's say a string of, we have an S of type integers, and this is gonna be like, say, for example, 1, 3, some numbers, that's fine, of a flexible size. And after that, what we're gonna do is like print is, obviously, this is not Python. You need to use format function. Okay, this is gonna give us, obviously, the whole slice, right? Now, let's do make it empty. What does it mean? It means reslice it. This time, is gonna be of is gonna be 0. So we, yeah, and I'm gonna just copy paste this one, but this is wrong. This is wrong because this is not what they are doing. Is 0. Of course, you need to put the slice name, right? Like this one, we'll say slice 1, okay? Because we just to make sure we are not getting confused. Undefined is 1. Oh, of course, right? You need to do this. What do you think is gonna happen? Make it empty. Is it gonna be empty? Actually, what I'm gonna do is I'm gonna remove this because we're actually working with the original slice, and I'm gonna remove this. Let's see what's gonna happen. Yeah, as we expected it, we are gonna empty the slice or reslice it to an empty slice, and that comes from here, which just means minimum length is gonna be 0, maximum is gonna be 0, so it's gonna be an empty slice. Okay, and now if I do is 0, 4, right? So we want a 4 from 0 to 4, and now if I print is, what's gonna happen? Hola, hola, hola. Look at that. Why that happens? Because when you reslice it, it actually doesn't change the underlying data structure, which is going to be an array. And that's why we still have access to those values because they're still stored in the memory. It's just that we are slicing it to an empty array. Okay, so the underlying values are not changed. Okay, and says this time I'm gonna drop the first 2 values. So I'm gonna drop the first 2 values now. S is equals to, how we're gonna drop the first 2 values? We're gonna say 2, that's like that. So we're gonna put 2 until end of the slice. And I'm gonna print this again. Yes, we dropped this one. Well, we dropped 2 values. It means from 0 to 2. So sorry, 2 values, this 2, yes, but where did go 8? Where's 8? I'm getting confused a little bit. Where's 8? Oh, sorry, we don't have 8. We don't have 8 because it's coming from this slice. So it's actually taking, because S is now a different, we resliced it. So that if we drop the, if we drop the 2 values, so we are dropping 1 and 3. So it's gonna, the only remaining part is gonna be 45 and 67. Great. And after that, print slice. Print slice. We have a print slice. Who knew? We have print slice. Did we even use it? No. Does it matter? I don't think so. You don't need to import format, I guess, then, or here. Okay, let's see what this function is. We have a function called parent slice. It's gonna take a slice, and it's gonna, what is it gonna do? It's gonna say, we'll see what is the length and what is the capacity of this slice. So it says length is gonna be an integer, capacity is gonna be integer. This percentage v is assuming this is gonna be a string, right? And we're gonna say the first value is gonna be replaced by length of s, the second value is gonna be replaced by capacity of s, and the third value is gonna be replaced by what? It's gonna replace by, oh, come on, man, what am I doing? I thought this parent slice is a built-in function. It is not. It's something we define here. Okay, great. Let's go and define it. Now we know how to define a function, right? So obviously not inside the main function. For function, what was the name? Parent slice, right? So, oh, I think I messed up the syntax. Func parent slice, and then it's gonna be taking an s of slice of integer, right? It's not gonna return anything, so it's gonna be empty. And here we're gonna use that format function dot print f, or print, or sprint. Is it printf? It is gonna be printf. Yes, it's gonna be printf. And we'll say length equals to percentage d, cap equals to percentage d. What am I doing? Percentage d. And what's the other one? And we have v, which is basically the whole slice itself. It's gonna be a type of a string. Okay, with printf, now you have to format it. The first percentage d is gonna be replaced by length of s, right? The second is gonna be replaced by capacity of s, and the third one is gonna be replaced by s itself. And now if we run, okay, we get the same thing, but obviously because we are not calling parent slice. So what I'm gonna do is I'm gonna copy all these, not copy, I'm gonna do some trick. I'm gonna say I'm gonna replace fmt dot parent line with what? With parent slice. Beautiful. So this time we will need to get a different result, and this time length is 5, capacity is 5, the array is 5, the slice is 5. This time length is 0, capacity is 5, but it's empty, obviously, because the length is 0. This is going to be length of 4, capacity of 5. That's totally okay, because we still have capacity. If the length is 4, capacity is 5, that's okay. Here, length is 2, capacity is 3, that's okay. What the tutorial is suggesting us to do is to see what happens when the length is greater than capacity. Okay? So what we can do is we can I want to make this s equals to make. How do you use make? Let me make func t type size integer type. Okay, we're gonna have int, we're gonna have capacity of length of, let's say 5, capacity of 5. Okay, no new variable left. I'm gonna paste it here, and we're gonna initialize it like that. I think we can just get rid of this already, right? Can we? Can we? How do you do that? How do you do that now? Expected operand found this. Okay. Okay. First of all, that is correct. So it's gonna create, but our initialization is incorrect. Because what? Why? It says expected operand found square curly brackets. So this is it because it should be like that? No, but that's not gonna be it. ChatGPT, where are you? I need your help. This is wrong. What is the correct way of assigning values to a slice made with make? Oh, here. I think because we are not passing here. These are square brackets, is it? No, that was not the case. Assigning values. Oh, of course. You need to do it like that. You cannot do it in one go. You cannot do it like this, right? So it's gonna be like that, but that's fine. But let's see what's gonna happen now. Okay, we still have it because we have a capacity of 5. Now what we're gonna do here after this statement, we're gonna say is 5, which is gonna be 6, right? 6 indexed, equals to some number, 35. What's gonna happen? What did I do? Sorry, I accidentally quit. And here I'm gonna say, I'm gonna just call the slice function, right? So, oops, go runtime error. Runtime error index out of range 5 with length of 2, because we have a capacity of, okay, we have a capacity of 5, but we are passing 6 items. Basically, we are making the array. Am I doing this right? I don't know. I'm suspicious of this approach, this approach, but we'll confirm. Okay. We can say that now we are adding the 6th array, but that is not possible because the capacity is 5. I know the length is 5. It means that's the range. It couldn't be a length of 5, which we already defined, but the capacity is already 5. So these operations all work fine because, hey, the capacity is 5. You can shrink and grow between 0 to 5. But what happens if you go beyond 5? Then obviously there's no memory allocated for it, because the space that go runtime allocated for this slice is fixed, is of capacity 5. It means wherever it is allocating this in the memory, there is no more space, to store this value or to reslice it. Okay, so here it says you can extend a slice length by reslicing it, provided it has sufficient capacity. So it means if I go to line 19, sorry, I will say 19K. Where is it? No, 10K here, yeah. And then I will just say 6 here, so it means capacity is 6. Our program would work, right? Because now we have capacity. No, we don't have. It says index out of range, range 5 with length 2. Oh, of course, because here we are reslicing. This is not, this is no more this anymore. It's not this because we are reslicing it, right? So we are using the same value s here, because here we are slicing it to 2. So we are removing the 2 values. Um, uh, oops. How can I comment out multiple 9s without first selecting it? That's what I forgot. No. Oh, I know. 2GCC. Yeah. Okay. In Vim, I use a plugin called commenter or whatever it is. So you can comment multiple lines by basically, if I press GCC, it's gonna print one line. It's comment one line, but if I say 2GCC, it's gonna print it's gonna comment out 2 lines. But anyways, my point is that here our capacity, our length is already 2 and our capacity is 4. And the capacity changed here from 6 to 4 because here we reinitialize it because our capacity was 4. 1, 2, 3, 4. So here the capacity is 4 and we drop the first 2 and here's the remaining. And therefore we cannot go beyond that because our capacity does not allow for it. There's a limit to it. Nil slices, the 0 value of a slice is nil. We also know that if you use make, right? If you use make, the memory allocation already happens. So when you say something like is, something like that, the memory allocation happens, right? But there's something, if I, instead of this, if I make this M and make it M here, what's gonna happen? This is gonna be, I think it doesn't matter. It doesn't matter, right? Because at the end of the day, a slice is a reference to the same array. I'm getting myself confused here, so let's read this. A nil slice has a length and capacity of 0 and has no underlying array. Okay, great. Var is end, format is ln blah 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 blah, nil. Yeah, because we didn't initialize it. Let's give it a try. Let's give it a try. Oops. For example, var I, this time it's gonna be of type integers. And fmt, beautiful fmt dot print line, we're gonna print line is, we're gonna, in this case I, length of I, and cap of I, right? I named it I. There it's M. It's S, but it doesn't matter. Okay, so now what I will say, if S is nil, in this case I is nil, right? Print line nil. Okay, this is gonna print nil, right? But here it's a why does it give me a warning here? In programming, do we care about warnings? The answer is no. We don't care about warnings. Unless if it's an error. Anyways, I'm gonna delete this function here. Oh, now it's, I didn't see the error. But anyways, let's see. It's nil. Of course it's nil. Okay. What is the purpose of nil? Why are we, is this just for your information? Is just letting us know that this is how it is, or there is a purpose to a nil? Yeah. Let's ask ChatGPT. ChatGPT. Oh, I have to ChatGPT. I got confused. I'm gonna close this one to make sure I'm not confused. Okay. And why do we even need nil slices? What does good docs is trying to tell us? Teach us. In Go, a nil slice is a slice that has no underlying value, has a length and capacity of 0. You can think of a nil slice an uninitialized or empty that hasn't been allocated any memory yet. Here's the key point. The 0 value for a slice type is a nil slice. When you declare a slice without initializing it, like this, Go gives 0 values, which is a nil slice. It is different from empty slice. Yeah, of course, it is different from this, which is a slice with a length of 0, but it still has an underlying array. Example from GoDocs. We have this creates a nil slice of type int. Since it's not initialized, it holds the 0. It holds value of it holds 0 value of slices, which is nil. Yeah. By the way, it's raining crazy here in Amsterdam, as always. So there's some sound from outside, which I hope you don't hear. And yeah. All right. We have a length of s is 0, capacity of s is 0, and this is true. We understand this. Key takeaway is that a nil slice is different from an empty slice. Okay. Because an empty slice doesn't mean that it's an empty slice means, hey, its values are not initialized, but it still exists in the memory. It's assigned to 0 values usually, right? If you don't put any values in a slice, and let's say you define a length of 5 and a capacity of 5, but you don't put any values. Let's see it live. Why not? Like for example, what I mean is, if I have s, in this case, a slice of type int, is I'm just gonna make an integer, a slice of a size and capacity of 5, but this time I'm gonna make it empty. And if I print this, dot print line is, it's gonna be of value 0. Here it complains about something. What is it complaining about? Oh, of course. What is this? Does it still complain? It says end of a statement. Okay. Expected semicolon found this. So you don't actually do an empty. This is empty already, right? Yeah. You don't actually do an empty curly brackets, because this is by definition an empty slice. But we know that it has allocated memory for it because the values are 0, as you can see here. We have a length of 5, a capacity of 5, all the values are 0. This is different than an empty slice, which we saw earlier, which is something like that. var I, right, is of type int. And if I fmt.println I, this is going to be empty. It's going to be an empty slice. I think I understand that correctly. I hope you do too. And yes, creating a slice with make. Since we, okay, this is something that we, maybe I jumped ahead without explaining that, yeah? Or did I explain that? Did I explain make? Because I used this make in the previous live stream or a couple of live streams ago. And yeah, that's why I used it here, but I'm not sure if you're familiar with it. I need water. Okay, weird thing is that I noticed that when I'm using wine glasses to drink water, I drink water more. Maybe because I can see the water clear. That's why probably that it, you know, like this. You can see the water. It's, I don't know. It for me, it works. So I'm gonna keep it that way. Wine glasses. All right. All right, we understand that now. I hope everything is okay because I just keep touching this mic. And I'm not sure even if everything is working fine. I hope so. Okay. We can check that by going here. Yes, we are all good. We are all good. We are all good. Okay. Do we need to go through this? I think we can read it, but we already know how to make with a slice, right? So like make, you give it a type and then a length, and if you don't specify a length and capacity, that's going to be dynamic. I'm not sure if length is necessary here, but if you don't, yeah, it's going to be a dynamic slice. Slice can be created with the built-in make function. This is how you create dynamically sized arrays. The make function allocates a zeroed array and returns a slice that refers to that array. This is 5, of course. To specify capacity, pass a third argument to make, something like that. Okay, we know that. We know that. We already use that. Slices of slices. Now we are talking. This is going to be a little bit more interesting now because it's going to get a little bit messy. Okay, and here we are also learning that there is already a package called strings. This is the first time we see that. So we have format for printing stuff, and then we have a string, which I am not sure yet what purpose does it serve. Slices can contain any type, including other slices. I think we could expect that. We could expect that from a slice. And here is our main function, creating a tic-tac-toe board. So we have a board. This is like multi-dimensional arrays. Multi-dimensional arrays. That's what it is, right? Multi-dimensional arrays. Yes. So if I remember correctly, that is the terminology from Java. But here it's called nested slices or slices of slices. So we have a board, and this is of an empty type, not an empty, because it's a slice, it's a flexible slice, and it is a slice of slices of type string. and then it it continue to have yeah, multiple slices inside it. But notice here, I think we need to break this down honestly, because this is very confusing in terms of syntax. I know that we need to decipher it. So let's come down here. So so it is gonna be an array. It's gonna be a slice of slices. Okay, it's gonna be an array of arrays. So in other words, it's gonna be something like this, right? So we're gonna say A and B. This is one slice, and C and D is another slice, but both of them are part of a bigger slice. So we need to specify two square brackets when we define that, one for this and one for this, or this, right? Am I right on that? So we need two, that's why we need two of these here. Okay. And of type string, and here are our slices inside the big slice. And okay. And when we say board, yeah, exactly. This is a good example. So let's say this one is called for example, let's put it X, right? And this slice is called X. So if I say X 0 and 1, what does it mean? It means this one, oops, let me make another color here. It means this one, what is that? I don't want to, okay, this is better. This one refers to here, index 0 of the slice, right? Index 0 of the slice, and then we slice that another, we take the index of 1 of that slice, which means this is going to print B here. So this one, this guy, is going to be specifically this. I hope I'm not making this complicated for you, but because it looks very messy, I know. But yeah, basically when we say this is X, and we have a slice called X, right? And then that slice contains another slice. Let's call it Y, for example. And when we say X 0, it means the first element of this index, this slice, and then the second index of that and that slice. So if I say X 1 0, what does that mean? That means that we have the second item. Again, it starts with 0, right? And the indexes start with 0, so it means this is the 1. This is number 1. This comes all the way to here. It means this. And 0 index, it means here. So it's going to be C. But we're going to see it in action as well. Okay. That's why this could be a little bit confusing, because of this double square brackets. But yeah, I don't know what is tic-tac-toe. I know you might be laughing right now, but hey, I've never played it, so I don't know. Maybe I have played it, but it is search Google. Let's see. Oh, this is it. Tic-tac-toe, knots and crosses, or X's and O's, is a paper and pencil game for two players who take turn marking the spaces in a 3x3 grid with X or O. The player who succeeds in placing a 3 or placing three or their marks is horizontal, vertical, or diagonal row first wins. So in this case, yeah, here, something like that wins. Okay. Okay. So if you I put, for example, X here, X here, X here, I win. Or X here, X here, X here, I win. So I give you a choice to put where you want to. But look at Google. Look at Google. Can I play it? Okay. I can play it. Interesting. I want to. Obviously, if I put X here, then it's not gonna work, right? And you know that this is already blocking me. So let's put it here, see what's gonna happen. Oh, it's gonna be happening. So if I put here X, where do you think it's gonna, he's gonna be here because he wants to block me this way. So let's put here just as an example. Oh no. No, no, I lost to Google. Tic-tac-toe, I lost to Google. But anyways, let's not get distracted and try to do this. I might need to refer to this because this is a little bit messy. As you can see, it is gonna be a little bit messy, so bear with me as I navigate through it. What I will do is I will just say tic-tac-toe. What is the string named here? What do we call it? It's called board. Board, and we initialize it to a flexible slice, or a slice basically, which is a flexible array. And its type is string. Okay, and here we have other string types. So we have yeah, I think the first one is good. No, I'm wrong. I should not accept suggestions from this guy. So we have a string. This is one slice, right? And then we're gonna say, yeah, like that. Okay, that's it. So we have a board declared but not used, that we don't care. And now the players take turn. So we have board 0, right? Board 0, and let's say player wants board 0 0, right? It's like, or is equals to x. Similar to how we marked it. And board, now the second player is gonna, for example, mark next to that. So this is gonna be, so the player 2 is gonna be picking the next one. So 0 here, reference to this, right? And 0 means this the first element of that slice, which is here. So player 1 is gonna mark the top left cross. This is player 1. Play again. Let's restart the game. Just make sure we understand. This is what player 1 selects, and player 2. Let's do this in code. So now player 2 played here. What does that mean? It means this is the first row, second row, third row. So it means we are gonna be working with slice number 3. In that case, player 2 is gonna be here. It's gonna be 2, and then this is gonna be 0, right? Because this is 0. Again, multi-dimensional array, similar to how we described it here. So yes, so that's how we, let's say now we want to if we put an X here, this player is gonna put an X here. I don't know. I'm just gonna choose this one. So this guy blocked me. So now here is 3-1 because 0. Well, let's put it 1, row 2, row 3, or let's say 0, 1, 2. So this is row 2, index 1, 0, 1. So row 2, index 1. That's what I need to mark it now as my next move. So this is gonna be 2, and this is gonna be 1, right? And this is gonna be X. Now, the player, Google in this case, played this part, which means it is first row, 0, second item. So here it's gonna be 0, 1, which is the second item. And he's gonna put O. Let's play more. I don't know. I need to think of a strategy, but this is not time for a strategy. I'm gonna mark here. And this means I'm just 0, 2, right? So it means this is gonna be 0 and index of 2, X. And what Google played is 1, 1. So this is gonna be 1, 1. Okay, so far there is no winner. If I mark here, Google is gonna mark here. Yeah, so what I mark is 1, 2. So, oops. I want to replace this to 1 because this is row 1, index 2. Yeah, and what Google played is, did he play this one? Did he play this one? Okay, I will know that. 1, 1. We played 1, 2. Yeah, we played 1, 2. And Google played 2, 2. Google played 2, 2, because this is the row number 2, 0, 1, 2, column number 2, 0, 1, 2. That's why we put it. So now we only have this option here. Nobody wins, I think. Game over, draw, XO. So we put 1, 0. So let's put here 1, 0. Right, so our board now should be now let's if we go back here and then print it, like we want to print the whole all of it for I equals to blah 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 blah. We want to format print if, right? We have a string dot join board I, and then with some space, right? Because we loop through it because it's a so for I equals to 0, we start from 0, right? I less than or equals to, is it equals to or only less than to length of board. We just increment I. After that, what we're gonna do is we're gonna use fmt module to print if, and it's gonna be a percentage s for a string, I believe, right? And a backslash n for a new line, and that's gonna be the value for that is gonna be string dot join. Oh, that's why we imported a string, right? So we didn't import a string here. Here I'm gonna say string. Is it strings or strings? Strings, right? Now we are talking. Now we are gonna use that to strings dot. Now you see this join method. Join concatenates the elements of its first argument to create a single string. The separator string sep is placed between elements in the resulting string. Okay, so in this case we're gonna say board I, and we're gonna concatenate that with a empty space. We have a bunch of warnings here. Do programmers care about warnings? I don't think so. That's exactly what our board looked like in Google. How can I see it? Because now the game is over. But yeah, basically, yeah, we can do it like that. Yeah, I'm sure it looks like that because this is a draw, right? Nobody won. Okay, now I know tic-tac-toe. That's amazing. Now I know tic-tac-toe. And we built our game. This is the first game that we built, but it's very static. But we are learning, and this is a hard concept to grasp for so many people, including me. I struggled with this a lot, but at the end of the day, think of this as a table. I would like to think of it as a table, right? So a table has what? A table has columns and rows. So we have columns here. Let me take another color. These are columns. 0, 1, 2. And then we have rows, right? We have rows. These are the rows. So we have columns and then rows, right? These are rows. So this could be anything here. So for example, here it could be X, Y, Z, whatever, or A, B, C. So this Y is located on index, and it's here also 0, 1, 2, right? This is what we were missing. So 0, 1, 2. So this exists on second item. So it's going to be 1 on the second row on the first column, right? From first column. Maybe it's the other way around in this case, but you got the idea. So it's 1, 1. So it's 1 from this side, 1 from this side. This guy is going to be on row 2 and column 2, because, well, here 2, here 2, here 2, here 2. And this is going to be on 0, 0, because we have 0, sorry, this is going to be 0, 0, x, because we have on column 0, row 1, sorry. And this is not a good example because 0, 1, 2 should be here. This is just a, yeah, I hope you understand it. I hope you understand it. Okay, we got this. Appending to a slice, this is also what we learned. I think you can use the append method to do that, something like that. It's common to append new element to a slice, and Go provides the built-in append function, which means it's going to change the underlying array and resize it, basically. The documentation of the built-in package describes append. Function append, we're going to take a slice of type T and versus ... T. I don't know what does that mean. The first parameter is of append is a slice of type T, which we understood, and the rest are T values to append to the slice. Oh, okay. These are T values to append the slice. The resulting value of append is a slice containing all the elements of the original slice plus the provided values. If the backing array of S is too small to fit all the given values, a bigger array will be allocated. The returned slice will point to the newly allocated array. A bigger array will be allocated. So it means inside memory, Go runtime is gonna destroy the existing array, create a new array, and on the same address, with the same reference, or something like that, right? So if you have an array of size, let's say 3, right? Let's say 1, 2, 4, right? This is our array. This is our slice. And let's say you call this, we have a slice, and we call this slice dot append, and you add one more integer here. I'm not gonna worry about the syntax here. For example, you're gonna append 6 here. Okay, what does that mean? If you don't specify a length and a capacity for a slice, by default, the length and capacity of this is gonna be a length of a length of 3, because 3 items, and a capacity of 3, right? This is already allocated in the memory. So what is going to happen is, when you append another item to the list, what is going to happen is, this array is going to be completely destroyed in the by Go runtime, and instead a new array is going to be created. This time 1, 2, 4, and 6. Okay, and this is gonna be our new S. But I wonder how the reference is gonna get updated. Let's ask ChatGPT. If we use append method to add items to a slice, first of all, does the existing array gets wiped out of the memory it means it's destroyed, and if so, how does Go runtime updates the references? Okay, the append function in Go is used to add elements into a slice. It's important to understand that slices in Go are just descriptors that are point to the underlying array. We understand that. Actually, when I say slice here, what I really meant is array. I think I should clarify it. Yeah. A slice is a wrapper to an array, right? Let's make that clear. Okay, so what it means? It means if it is, it simply adds the new element to the existing array, and the slice length is updated. However, if the capacity of the slice is exceeded, Go runtime must allocate a new array with a larger capacity, copy the existing data to the new array, and then return the new slice descriptor pointing to the new array. Okay, I think that's pretty much clear. I'm not gonna bother with moving forward. Basically, if an array is updated using an append method, right? If the capacity allows for it, Go runtime is going to extend it. If the capacity doesn't allow for it, Go runtime is going to create a new array and replace the existing array, basically. But I wonder if I define a slice literal, such as x is equals to int, right? And this is going to be 1, 2, 3. Here I did not specify the length or capacity, so the default should be 3 and 3. And does that mean this, the underlying array, let's keep the terminology correct, gets destroyed in this case? I think probably it explained it here, but I just want to get answer to a specific question. This means that the slice has a length of 3 and a capacity of 3. If you try to append element to it, the capacity will be exceeded, and Go will reallocate a new array with a more capacity. In this case, you're creating a new slice using a literal. So let's break down the behavior. The slice X created by the literal will have its own underlying array to store the new values. Since the slice is created using the literal, the underlying array will not be destroyed immediately. Go will keep that underlying array alive as long as the slice X is in use or there are other references to it. Interesting. That's what we were missing, right? If you append to the slice and it needs to allocate a larger array because the capacity is exceeded, Go will allocate a new array and the slice descriptor will update to point to the new array. Okay. If you append to the slice and it needs to allocate a larger array because the capacity is exceeded, Go will allocate a new array and the slice descriptor will be updated. At that point, the old array is no longer referenced and become eligible for garbage collection. It won't be destroyed immediately, but it will be cleaned by Go's garbage collector when it is no longer needed. I think our theory was correct, if I understand this correctly. So if there is already a reference to the old array, obviously Go runtime is going to keep it. But if it is not, then it's going to be replaced by the new array, but it's just going to be an orphaned object in the memory waiting for garbage collector to come and grab it and throw it out. I hope I understand that correctly, honestly. Okay. Let's go through this example. We have a print slice again, which we already wrote this function, so I don't want to rewrite it. Instead, I'm gonna add it here. Okay. No, not here. Here, of course. And let's come here and define var is of type flexible int. Am I correct? And we got if we print slice is, what's gonna happen? It's gonna give us, but we have a bunch of stuff that we don't use here. So let me remove that. And it's gonna be length of 0, capacity of 0 because we have not initialized it. Okay, that's good. Now we append one item to it, right? So is equals to append is 0. We're gonna append 0 and then we're gonna print. This is gonna be capacity of 1, length of 1. Correct. And the item is 0. Okay. And if we is equals to append, and let's say we append 2 in this case, what is it, 1, or it doesn't matter, and print slice again, what's gonna happen? 0, 2. Okay, nothing crazy, and we can add more than one element at a time, so you can add multiple elements, obviously. So let's put it here. So instead of here, we can add is.append and then specify 2, for example, 5, whatever, and print is. This time it's gonna get expanded like that. as we expected it. Nothing surprising here. Okay, okay, nothing surprising here. Okay, okay, there's something wrong with my finger. What happened to my finger? Did I type too fast? It feels like I cannot feel it anymore properly. Okay. All right. Hopefully that's not a uh, serious thing. We also have range. We have seen the setting somewhere, but range basically gives you range for a slice. And let's we have a slice here of type integer, and what happens is for I and then v equals to range of pow, right? Format.print.I iv. So range pow. Okay, let's read this. The range form of the for loop iterates over a slice or map. Okay. It means this range belongs to a for loop. You can use it inside a for loop. This has nothing to do with slices. When ranging over a slice, two values are returned for each iteration. The first is the index and the second is a copy of the element at that index. When ranging over a slice, two values are returned for each iteration. Okay. The first is the index and the second is the copy of the element at that index. Okay. Why they say the copy of element? Why don't they say that? Okay, that's the part that I'm confused about. When ranging over a slice, two values are returned for each iteration. The first is the index and the second is a copy of the element at that index. Okay, so for I, v is range of pow. I know that this is a shorter version, right? Like shortened, but yeah, that's why you don't see the plus and stuff. That's how you define range basically. And then we're gonna say 2 asterisk percentage d equals to d. We have I and v. So it means 2 times I equals to v. 2 times I equals to v. I don't know if I understand this actually. Let's ask our friend ChatGPT. I struggle to understand the following. Explain it simply. In Go, range keyword is used in a for loop to iterate over collections like slices, arrays, maps, and channels. When you use range with a slice, Go will return two values for each iteration: the index of the current element and a copy of the element at that index in the slice. Oh, so it means it doesn't a copy of the element at that index in a slice. So it means it's gonna copy it over to somewhere else. It's not a reference to it, unlike pointers. It's not a reference, but a copy of it. How range works? Let's break it down. So we have a number 10 to 20, 30. Now, if you want to loop over the slice and print the index and value of each element, you can use range in a for loop like this. Okay. That's going to print I and V. What happens in each iteration? This is the index of the element. With I have no problem. I understand the whole thing, but I don't understand the copying part. What does the copying mean here? This is the index. It's gonna print the index. It's gonna be like, for example, this is gonna be 0, 1, 2. Basically, I is gonna be in the first iteration. It's gonna be 0. Second iteration is gonna be 1, and third it's gonna be 2. Right? Yeah. Okay. And we're gonna format dot print line I and v. What happens in each iteration? V. This is a copy of the element at the current index. In this case, it will be a copy of the numbers at each index in the slice. Okay. Why is it a copy of the element? Which is very interesting. Slices and arrays hold references to the actual data, but when using range, the loop receives a copy of the element, not reference to the original element. This is important if you need to modify the elements during the loop, because modifying v will not affect the original array. Now it makes sense. Now I know why. Because we don't want to modify the original array. That's why we copy it. So that's the default behavior of a range. Okay. You can escape the index or value by assigning this, which we already know. So if you want to index, this is an underscore, which is gonna escape the value. This is gonna escape the index. Okay, nothing interesting here. Exercise slices. Okay. I think probably I need to stop here. Is it already more than 2 hours? Ah, it's already more than 2 hours, man. And exercises, as we know it, is not easy. In the last exercise, we were struggling quite a bit. So I don't want to spend a lot of time here. We are already past the 2 hours mark anyways. So we're gonna keep continuing with this in the next live stream, hopefully tomorrow, but we'll see. And yeah, I hope this is useful to you, whoever is watching. And yeah, if you made it up to here, thank you so much for staying around. Please hit the like button, subscribe to my channel, show some support to me, and I will definitely see you in the near future in the next stream.